Okay, this is the problem we'll be working with in this video. 35.5 grams of silicon dioxide and 66.5 grams of hydrogen fluoride react to yield 45.8 grams of H2SiF6 and the following equation. And this is the balanced equation. So, what we're going to do first before we get to the questions of the problem is convert the grams of silicon dioxide and hydrogen fluoride to moles of H2 silicon fluoride 6. So we can figure out what the limiting reactant is and what the theoretical yield is. So first, with silicon dioxide, we're converting the grams to moles, so we have to use a conversion factor. So we have the 35.5 grams times 1 mole over 60.09 grams, which is the molar mass of silicon dioxide. And then to get it to H2SiF6, we did the the mole ratio. So in the equation, for 1 mole of silicon dioxide, there's 1 mole of H2SiF6. And we ended up with 0.591 moles of H2SiF6. So now we're going to do the hydrogen fluoride one. So we were given 66.5 grams of hydrogen fluoride. And then we're going to multiply it by a conversion factor to put it to moles, which the molar mass is 20.01 grams. And then we're doing the same mole to mole ratio. So for 1 mole of H2SiF6, there are 6 moles of hydrogen fluoride. And when we multiply this out, we got 0.554 moles of H2SiF6. So with this information, we know that the hydrogen fluoride is the limiting reactant because it has the smaller amount. So now that we know this, we can move on with the actual questions. So the first question for problem number 4 was how much mass of the excess reactant remains after reaction ceases? So our excess reactant was the silicon dioxide because it had the most amount of moles. So we're just working backwards and converting from the moles of H2SiF6 to grams of silicon dioxide. Notice how the 0.554 was the amount of moles that we got from converting hydrogen fluoride, and since that was a limiting reactant, that is going to be how much was used for the whole equation. So instead of using the 0.591 moles that was given from the silicon dioxide, we used the 0.554. So this number is how much mass of silicon dioxide was used in the reaction. So now we're going to subtract this number from the given number, 35.5 grams, to find how much was left over. So there were 2.2 grams of silicon dioxide left over after the reaction. So the second problem, or the second question, was what is the theoretical yield of H2SiF6 in grams? So basically this is the same equation that we did in the beginning from hydrogen fluoride, but we're going to convert it into grams of H2SiF6 instead of moles. So we did the same conversion factor and the same mole-to-mole ratio. And then we're going to do another conversion factor back to grams. So we ended up with 79.8 grams of H2SiO6. So this is the theoretical yield of H2SiO6. Okay, so our third question was, what is the percent yield? So we took the experimental yield, which they gave us in the problem, which was 45.8 grams of H2SiO6, and divided it by the theoretical yield that we just found in the last problem, and times it by 100, so our percent yield was 57.4%. So finally, our last question was, what kind of reaction is this? And this is a double replacement reaction because all of them switch. So the O2 that was with the silicon in the beginning is with the hydrogen, and the fluoride that was with the hydrogen in the beginning is now with the silicon. So that's it.